Okay, so we'll take the first about 15-20 minutes taking up some of the homework questions, and then I'll let you guys work on the next review page. So number one of the question, you're given the diagram, and it's simply just doing SOHCAHTOA, opposite over adjacent, to find the height of the pole. So number one, pretty straightforward, pretty easy. Number two says find the length of the wire. So after you find the height, of the pole and the distance away from the pole, what are two ways for you to find this length right here? The length of the wire. What are two different ways? You use cosine, right? So you could do SOHCAHTOA again using the 5.6 and the hypotenuse. What's the second way? After you find the height of the pole. Yep. Sorry? Pythagorean theorem. Yeah, you're given two sides. So don't forget this easy method that you guys learned in grade 8. Pythagorean theorem. So 5.6 and this height, c squared equals a squared plus b squared, to find the diagonal, the hypotenuse. Okay. Number 3, similar. Number 5. Okay, so let's go over number 5. So number 5, Jack and Sanchita are facing each other on opposite side of a 10-meter pole. So I have this right here. Okay, let me move this over. Okay. Okay, and then from Jack's point of view, the top of the flagpole is at an angle of elevation. Remember we went over this word, angle of elevation? So it's this right here. That's you looking up at the flagpole. So angle of elevation is 50. On the other side, Sanchita is right here. Angle of elevation is 35. Now looking at this, how many triangles do you see in this diagram? How many triangles do you see? 3, right? This red one, this blue one, and this big one. All right. Now I know I'm looking for the distance between them, but this right here, this big triangle, is not a right angle triangle. Based on what we've learned so far in this chapter, we only know how to solve it if it's a right angle triangle. So we cannot solve this all in one step. We have to divide it into 2 parts. So notice if you do it like this is right angle triangle, so I can do SOHCAHTOA. So 10, 50 degrees equals opposite, which is 10, over adjacent, which is A. Since my variable is on the bottom, I know I have to divide. So 10 divided by 1050 on the calculator, I get 8.4. Same thing on the other side. This blue triangle, opposite over adjacent. So 10 over A. So tangent 35 degrees equals 10 over A. My variable is on the bottom again. So I would divide. So 10 divided by tangent 35. I get 14.3. So now that I know this part is 8.4, this part is 14.3, to find the distance between them, I would add it. And so they are 22.7 meters apart. Okay. And then number 6, Alexa and Emma are looking up at their house from the backyard. From Alexa's point of view, the top of the house is at an angle of elevation of 40 degrees. From Emma's point of view, directly closer to the house, it's 60 degrees. The house is 15 meters high. How far apart are the 2 girls? So does that mean for number 6, I draw the exact same diagram with Alexa and Emma?
I'm saying.
Hi.
How you doing?
I'm good.
Long time no see.
Yes. You can visit more.
Yeah, I understand.
But your buddy is not here today.
Who?
Radeep?
Is that here? I'm off to patient, to be honest, you know.
Yes.
I got
Please
you.
do.
I got you.
Okay, make him come. Make him pass.
Got you, Miss.
Okay. Okay. So for number 6, am I drawing the exact same diagram, but just instead of Jack and Sanjita, it's Alexa and Emma? Okay, who says same diagram for number 6? Who says different diagram? Okay, How Ming, why is it a different diagram? You're right. Two, right. Okay, and Xiao, how is this diagram different than your diagram in number 6? Right. So this is the diagram for number 6. So the difference between number 5 and number 6, number 5, they're standing on opposite sides. Number 6, they're standing on the same side. Right? And it will make a big difference. All right, so instead of Emma being over here, you have Emma over here. Okay. How many triangles do you see in this diagram? 3. Yeah, there's actually 3. There's this big one, there's this small one, and then there's also this one right here. Okay, but again, this small one, I know I'm looking for A to E, but this right here, this is not a right angle triangle, so I cannot use SOHCAHTOA on this small one. So what do I have to do? Find the distance of this whole length, find the distance of this length, and now I'm going to subtract it to find the distance between A and E. Better? No? Do you want to get ice? You can get ice from the ice.
It's fine. I just want to wash it with the water.
Water is not going to help, and it's actually worse because it's
like temporarily makes it better.
You should go down to the office, ask them for ice. All right, so find the distance of this, find the distance of this, and then subtract it to find the distance between A and E. All right, so that's number 6. So what makes number 6 hard is they didn't give you a diagram. So I think for this chapter, the hardest part is drawing that diagram. Once you have that diagram, it's just SOHCAHTOA. It's easy.
If you draw the diagram incorrectly but with the correct measurements and you get the answer right, would you get points off?
Well, your diagram is going to be worth a mark. So if all your calculation is right, you'll get the mark for the calculation, but you'll lose the mark on the diagram.
Another question. So for question number 6, how do you know that it's all on the same side? Like, is there a keyword?
So for this one, it says directly closer to the house. Yeah, so which means they're on the same side. And then this one right here, it will say opposite side. And this one is at each on the opposite side. So that's how you know where they're standing. Right. Number 7, you're given a diagram, so it should be nice and easy. So you have 2 vertical poles, which are this and this. And then you have the 2 wires. So think logically. Think logically, where is that wire? Where are the 2 wires? Think logically in real life, how do you attach a wire to something and stick it to the ground? So which one of these lines are the wire? I see a whole bunch of lines. Right? Yeah? The diagonal ones, right? That's how you anchor things. So the diagonal ones are your wires. So these 2 are the wires, and you're looking for the angle the wires make with the ground. So it means like this. Alright, so these are your 2 wires right here. And again, you're looking for the right angle triangle. The fact that it tells you it's 2 vertical poles means that the angle right here is 90 degrees. The angle right here is 90 degrees. So here's one right angle triangle, and here's your other right angle triangle. So let's say I'm just solving for angle A. Tangent A equals opposite over adjacent, so 15 over 6. You get 2.5. So to find the angle, I have to use the inverse. So tangent inverse, 2.5, you get 68 degrees. Okay, so that's how you find the angle. Okay. And then again, for part B, it says how do you find the length of it? Well, you're given two sides. So easiest way, Pythagorean theorem. C squared equals A squared plus B squared. Technically, you could use the 68 degrees and then do SOHCAHTOA to find the length. But because you found this answer, if this answer was wrong, you would have got the carry on instead. So I would suggest using Pythagorean theorem because you are given the two sides. Okay. Number 11. Okay, so number 11, the question broke it up into three parts for you guys. So it was asking how high is Captain Jack, and then it asks you how long the ship is, and then it asks you how long is this wire, this dotted line. Right. So this question, it broke it up into three parts. On a test, I could just jump to part C and ask you how long is this dotted line. Okay. Because if I just ask you how long is this, you would have had to do part A anyway. Okay. So find this first before you can find this length. So this is what I did. So given this diagram, I have a right angle triangle here. I want to look for the height of the Captain Jack. So opposite over adjacent. So tangent 30 degrees equals 20 over A. Since my variable is on the bottom, I divide and I get 34.6. So I know the height of Captain Jack. This is 34.6. Now I want to find the length of the wire. So adjacent over hypotenuse. So A and H, it means I should use cosine. So cosine 70 degrees equal adjacent over hypotenuse. Okay, variable is on the bottom. Again, that means I'm dividing. So 34.6 divided by cosine 70, I get 101.3. Okay, don't forget your unit is in meters. Length is always centimeters, meters, kilometers, angles, degrees. Okay. So, as I was saying, I could have just asked this question as, given this diagram, find the length of the wire. And then we would have to know to do this first and then do that. Okay, last question, number 14. Okay, number 14. Again, I don't give you a diagram. That's what makes this question hard. The observation deck at Piggy's Cove Lighthouse in Nova Scotia is about 20 meters above sea level. From the observation deck, the angle of depression of a boat on the water is 6 degrees. How far is the boat from the lighthouse to the nearest meter? So let me draw a diagram. Okay, so this is the lighthouse. That's you right there on top of the lighthouse. And then you see a boat. That's a boat. That's a person rowing the boat. Alright, and you want to find out this distance. Okay, you're looking down at them. Hello. Alright, obviously my drawing is not to scale. Alright, so angle of depression. Does that mean this angle right here is 6 degrees?
Oh, sorry, I just want to ask a question about the drawing.
Oh, my drawing. Yes, it's not to scale.
Does it have to look like it's on scale, or at least
No.
pretend that it is?
No, I'll go by the numbers. It doesn't have to be to scale. So, my angle of depression to the boat is 6 degrees. So does that mean me looking at this person on the boat, this angle right here is 6? Is this 6? Who says yes, this angle right here is 6? Who says no, that angle right there is not 6? Oh, hey, Caitlin, where is the 6?
It's the one by the boat.
This one right here?
Yeah, that one.
This one? But is that an angle of depression? Well, I can tell you this is 6. Okay, but that's not angle of depression. This is angle elevation. Okay, but why is this 6? Right? Okay. But where is the 6 degrees? Where is my angle of depression? Yeah?
I was just gonna ask, can you explain what angle of elevation?
Oh, you weren't here Friday. So that's what we talked about on Friday. Angle of depression, angle of elevation. So, what was the definition of angle of depression, angle of elevation? You have to look from... Right, from where? From your feet? From eye level. So you actually have to draw an eye level line right here. From your eye level looking down, that means this right here is 6 degrees. Oh, okay. So I do have my right angle triangle right here. All right, so there's a couple of ways I could solve this right angle triangle. If I know that this is 6 degrees, how big is this angle then? What's that angle? Complementary angle? 84. Right? Remember, these two angles have to add up to 90. So if this is 6, this is 84. I could use the 84 to figure out the length of this. This is 20, by the way. All right. Or, so as Caitlin, you were saying, this is 6 degrees. What made this 6 degrees? The two different ways. Alternate angle. Z pattern. Remember that from last year? So if this is 6 degrees, then this is also 6 degrees. This angle right here is also this angle. Okay. So, so sometimes you will get the right answer by fluke. Alright, but if you draw the diagram, that's why your diagram gives you a mark as well. Because if I saw that you drew the 6 degrees right here, your diagram is wrong. This is your angle of depression looking at the boat. This is your angle of elevation looking up at the lighthouse. Okay. It just happens that because of alternate angle that they are the same.
Does the angle of elevation also have an eye level?
Yeah. So for those of you who were absent on Friday, then from your eye level looking up, that would be your angle of elevation.
What about the guy on the boat?
Yeah, same thing. So eye level, and then looking upward. This would be their angle of elevation. I just drew the person a little too high. So he's sitting down. Okay. So now that we have this diagram, then we can do SOHCAHTOA. Okay, so looking for this length right here, using the 6 degrees. opposite over adjacent, so 20 over x, divide, you get 190.3 meters. Right? Okay, one last conclusion I want to make with you guys. So let me give you guys a few scenarios and then you tell me what you should use. Okay. Got it? Okay. So given this, if I need to solve for, I can actually solve for everything in this picture. What should I use? Should I use SOHCAHTOA or should I use similar triangles? SOHCAHTOA or similar triangle? SOHCAHTOA. Okay. What if I give you this? All right, SOHCAHTOA or similar triangle? SOHCAHTOA. Okay, what if I give you this? Right, SOHCAHTOA or similar triangle? Huh? All right, well, similar triangle, I need two triangles. Yeah? Can't. All right, neither similar triangle or SOHCAHTOA. In order for you to use SOHCAHTOA, I need to be given at least one length. So either one length or two lengths. If I give you two angles, I can't do anything. I just know that it's a triangle that has these angles, okay? But it's not enough to solve for the lengths, right? So I can't do anything. Like it's not solvable. Okay. What about uh, 40, I don't know, 28, something like that. Okay, what about this one? SOHCAHTOA or similar triangle? Why? It's not a right angle triangle. Right? So again, can't do SOHCAHTOA because it's not a right angle triangle. I never said this was a 90 degree. Okay, so can't. Okay. What about 20 degrees? 5, 10. Alright, what about this? What can I use? Yep. Similar triangle. Right. Okay. So even though this is not a right angle triangle, but I have two triangles. I have this triangle right here, and I have the big triangle right here. So I could use similar triangles. All right. So the key right here, you have two triangles, so you could use similar triangles. Another one like this. Okay, and I give you some length, 2, 6, something like that. Okay, what about this one? What can I do? Oh, and here. Okay. Huh? Both. Good job. This one I can use both. All right, because it's a right angle triangle, and also I have two triangles. So this is a this is a similar triangle to this. Right, so in this case, I could use both as well.
Isn't it not proportional? It's 5,
Yeah.
15 is 20, and 2 is 6.
Yeah, it's not. It just should be 10. No, this should be 10. Yeah, this is 10. Then it's proportional. Okay, how did Ryan find that out? Because if I redraw my two triangle, this is 2 and 5, and my bigger triangle would be 6 and 15. Okay, that's a lot of people fall for this. This is not 10 right here, because if you just do 6 and 10, this is not a triangle. This is a trapezoid. Okay, where's your other triangle? Your second triangle is this one right here. And the length of the whole length right here is 15. Okay. Hi.
Okay.
Sure. What's the K value? Yeah, 3. So K is 3. Okay. So remember the formula? Area of the large rectangle is K squared times the area of the small triangle. All right. So remember this one formula. So on the test, you have to remember SOHCAHTOA, the spelling of SOHCAHTOA, and this one formula, and Pythagorean theorem. All right. What's Pythagorean theorem again? C squared equals, right. What is C? Hypotenuse. Okay. Oh, and also when you do these questions and when you're solving it, when you solve for any of these ones right here, remember your hypotenuse has to be the longest side. So let's say you do SOHCAHTOA and you get the answer here is 18, you know it's wrong. Okay, because it has to be bigger than 20. Okay, so keep those in mind. Those are the little tricks that I want you guys to know. So I think the hardest part to this test is to draw the diagrams. All right, so here are some word problems for you guys to try. It has similar triangles and SOHCAHTOA stuff on here. So use the rest of the class to try these ones. We'll take up these tomorrow. Okay, so you can see some requires you to draw your own diagram. Okay, so let's work on this. We have a good 45 minutes.